Hello friends, welcome to my channel. These are all educational purpose video channel. You can search my all the videos by typing Pravinesh publication on YouTube. If you like my videos, then please press the bell icon which is given in the corner, that is yellow color button. Please press the bell icon so you will get each and every update. Friends, watch my videos till end so you will understand each and every concept. Today I will explain standard number 9, chapter number 1, matter in our surroundings. Friends, the heading of the chapter that includes the word matter. What is the meaning of matter? A simple meaning of the matter is a substance. Now what is matter? What is the definition of a matter? Definition of a matter: anything that occupies space and has mass and volume is known as matter. There are many different theories about how this matter is made up of. So the simple theory is that matter is made up of 5 basic elements. Which 5 basic elements? That is air, second one is earth, third one is a fire, fourth is sky, and fifth is water. So matter is made up of these 5 basic elements. Now there are different theory regarding how matter is made up of. Some of the theory they say that matter is in continuous form of a block. Other school thought that the matters, they are made up of particles. Now let us understand from the textbook. Friends, if you don't have textbook, then you can download it from the Google Play Store on your mobile. That is very easy. Even I have downloaded the textbook from the Google Play Store and took out the printouts. I have these printouts. Now if you have a physical textbook, then focus in the textbook. Topic 1.1, physical nature of matter. Topic 1.1.1, matter is made up of particles. In that activity 1.1, take a 100 ml beaker, fill half the beaker with water and mark the level of water. Dissolve some salt or sugar with the help of a glass rod. Observe any change in water level. What do you think has happened to the salt? Where does this disappear? Does the level of the water change? Friends, when we add salt into water, so salt will dissolve into water. So the water level does not raise. Actually friends, what is the meaning of dissolution? For example, these are the water particles. Water particles, they have a space in between. This blue color circles I have drawn for the water particles. There are some space in between, and these red color particles are salt particles. So when we add salt into it, the size of a salt particles are smaller than the water particles. So these salt particles will take place between these water particles. So this is the process of dissolution. Can you dissolve wood into the water? No. Why? Because the size of the wood particle is much larger than the size of the water particle. Whatever the space between the water molecules have, the salt particles can take place in between because the size of a salt particle are smaller than the space between the water molecules. Now, in order to answer these questions, we need to use the idea that matter is made up of particles. What was there in the spoon? Salt or sugar has now spread throughout water. This is illustrated in figure 1.1. You can see the figure 1.1. When we dissolve salt in water, the particles of salt get into the space between particles of water. So by this activity we can say that the matter is particulate. That means matter is made up of particles. Now friends, from the textbook, topic 1.1.2, how small are these particles of matter? To understand this, we need to do activity 1.2. Take 2-3 crystals of potassium permanganate and dissolve them in 100 ml of water. Friends, formula of potassium permanganate is KMnO4, which is purple in color. You can see this substance in your school laboratory. Take out approximately 10 ml of this solution and put it into 90 ml of clear water. Take out 10 ml of this solution and put it into another 90 ml of clear water. Keep diluting the solution like this 5 to 8 times. Is the water still colored? Friends, in the figure you can see that each and every time the solution will become pink, but the color fade up at each and every consecutive dilution. Friends, even you can take the Dettol. Just take a few drops of Dettol and put it in a water. You can get the smell of Dettol. If you take few spoon of this solution and put it another beaker of water, even you will get the smell of Dettol. So after each and every dilution, you will get the smell of Dettol. So by this activity we can suggest that the matter is particulate, that means it is made up of particles. Now friends, important topic, that is topic 1.2, characteristics of particles of matter. We understood that matter is made up of particle by different activity. Now this matter have some characteristics, these particles have some characteristics. So these are known as characteristics of particles of matter. There are 3 characteristics of particles of matter. The first is particles of matter have a space between them. The second, particles of matter are continuously moving. And third, particles of matter attract each other. So these are the 3 different characteristics of particles of matter. Let us understand one by one. The first is particles of matter have a space between them. Friends, we dissolve salt or sugar in previous activity and we saw that there was no change in the water level remains same. So we can say that particles of matter have a space between them. Now second, particles of matter are continuously moving. Friends, there are different activity. First, I'll explain by day-to-day routine activity, that is in your home also. When you come back from the school, your mother cook food and you will get the smell of that food by sitting several meters away from the kitchen. Why? Because when your mother cook food, at that time particles will gain some heat, so they will vibrate and then they have a kinetic energy. Friend, word kinetic energy is very important. What is this kinetic energy? The simple meaning of kinetic energy is when particles gain energy due to its motion is known as kinetic energy. So when you sitting outside the kitchen, you will guess that what was cooked in your kitchen. Why? Because that is due to this property, particles of matters are continuously moving. Another example, if you lighten incense stick, that is agarbatti, in a room, so you will get the smell of this incense stick several meters away from it. So why? That is due to this characteristics, that is particles of matter are continuously moving. Now from textbook, activity 1.3, put an unlit incense stick in a corner of your class. How close do you have to go near it so as to get its smell? Friends, whenever it is not lightened, you need to go very close to it to get the smell of it. Now light the incense stick. What happens? Do you get the smell sitting at a distance? Yes. When this incense stick is lightened, so the fragrance of this incense stick will spread towards a distance. That means you can get the fragrance of this incense stick when you are sitting several meters away from this stick. Now activity 1.4. Take 2 glasses or beakers filled with water. Put a drop of blue or red ink slowly and continuously and carefully along the sides of the first beaker and honey in the same way in the second beaker. Leave them undisturbed in your house or in a corner in the class. Record your observations. What do you observe immediately after adding the ink drop? What do you observe immediately after adding a drop of honey? How many hours or days does it take for the color of ink to spread evenly throughout the water? So here we have two cases. In one case we add the ink into the water, and in second case we add honey into the water. When you put ink drop into the water, so it immediately spreads throughout the solution. Friends, you can do this activity. Friends, now we'll explain the second characteristics. Particles of matter are continuously moving by simple activity that even you can perform at home. Take a glass filled with water. You can see that the color of this water is transparent, that is a clear solution. Now when we add red ink into it, you can see that immediately the color of water change. So here you can see that we don't need to stir the solution. So particles are continuously moving, so they uniformly spread out this solution. You can see that now color of this water will become red, that is due to red ink. And in second case, when you add honey into water, so it will not spread throughout the solution, it will remain same after few days. Now next activity, that is activity 1.2.3, particles of matter attract each other. From textbook, activity 1.6, play this game in the field, make 4 groups and form human chains as suggested. The first group should hold each other from the back and lock arms like Bihu dancers that you can see in the figure. The second group should hold hands to form a human chain. The third group should form a chain by touching each other with only their fingertips. Now the fourth group of students should run around and try to break the 3 human chains one by one into as many small groups as possible. Which group was the easiest to break and why? Friends, here we have 3 groups and the fourth group is running and try to breaking the chain. So which group is easy to break? Here the group which touch with each other by the finger, they are very easy to break. So by this activity we can say that particles of matter attract each other. Another example, when the water is flowing from the tap, can you cut that flow? No, which is not possible to cut that flow. Why? Because this property, particles of matter attract each other. Now friends, next topic is states of matter. In your textbook, there are 3 states of matter, that is solid, liquid and gas. Actually, there are 5 states of matter. The remaining 2 are plasma and Bose-Einstein condensed state. But we need to take the information about only these 3 states of matter that we know, that is solid, liquid and gas. Friends, on the board I have drawn the diagram of solid particles, liquid particles and gaseous particles. We can see that in solid they are particles tightly packed with each other. That means there is no intracellular space or intraparticular space. In liquid there is some gap between the particles, they are spread apart from each other. In gaseous they are widely spread, that means they have a much more intraparticular space. Now in activity 1.11, take 300 ml syringe and close their nozzles by rubber corks as shown in the figure. Remove the pistons from all the syringe, leave one syringe untouched, fill water in the second and piece of chalk in third. Insert the pistons back into the syringe. You may apply some Vaseline on the pistons before inserting them into the syringe for their smooth movement. Now try to compress the content by pushing the pistons in each syringe. Friends, here we have taken 3 syringes. In first we have fill up the chalk powder, in second we have fill up the water, and third we have not fill up anything, that means it has gases. Now try to press the pistons. You observe that in the gaseous pistons it will press easily. In liquid you can apply the some pressure, but in chalk powder you are not able to apply any pressure. So by this activity we can say that solid cannot be compressed, liquid they can be compressed, and gaseous, they are highly compressible. We have observed that gases are highly compressible as compared to solids and liquids. The liquid petroleum gas, that is LPG cylinder, that we get in our home for cooking, or the oxygen supplied to hospitals in cylinders, is compressed gas. Compressed natural gas, CNG, is used as a fuel these days in vehicles. Due to its high compressibility, large volumes of a gas can be compressed into a small cylinder and transported easily. We come to know of what is being cooked in the kitchen without even entering there by the smell that reaches our nostrils. How does this smell reach us? The particles of the aroma of food mixed with the particles of air sprayed from the kitchen reach us and even farther away. The smell of hot cooked food reaches us in seconds. Compare this with the rate of diffusion of solids and liquids. Due to high speed of particles and large space between them, gases show the property of diffusing very fast into other gases. In gaseous state, the particles move about randomly at high speed. Due to this random movement, the particles hit each other and also the walls of the container. The pressure exerted by the gas is because of this force exerted by gas particles per unit area on the walls of the container. Friends, on your screen you can see the solid, liquid and gaseous state, that is figure 1.a, and the space between the particle is different. Here friends, the word diffusion that we understood from the biology chapter, diffusion means what? Again we revise. Intermixing of particles on their own is known as diffusion. Now, diffusion of gaseous into gaseous, which is an example of diffusion in which gas diffuse into gas. So that is air. We know that in air many gases diffuse with each other like oxygen, carbon dioxide, nitrogen. Next, gas into liquid. So here we can give example, oxygen dissolves into water so that aquatic animals can breathe. Next, gas into solid. So carbon dioxide makes the bread and cake fluffy. So when carbon dioxide mixes with the solid particles, so it makes the bread and cake fluffy. Now next, liquid into liquid. So here we did the activity before, that means ink dissolves in water. So this is the example of liquid dissolves into the liquid. Next, liquid into solid. Friends, when we add water into sugar, so this is the example of liquid diffuse into the solid. Now, solid into solid. Friends, example of it is alloys. What is the meaning of alloy? Intermixing of two metals is known as alloy. We have an example of alloy like stainless steel. So that is the example of solid to solid. Now here we discuss different examples. Now discuss the rate of the diffusion. Friends, diffusion of gas into gas is very fast. Why? Because the particles of gas, they have a wide space in between, so they immediately mix with each other. Diffusion of gas into liquid is somewhat slower than the gas into gas. Same as diffusion of liquid into liquid is also faster, but not such as in gas into gas. Diffusion of solid into solid is not so faster, that is very slow process. So these are the example of diffusion of one states into another state. Now friends, on your screen you can see the general properties of solid, liquid and gas. Solid, they are rigid, they have a fixed shape and fixed volume. Liquid, they are not rigid, not fixed shape and fixed volume. Gas, they are not rigid, no fixed shape and no fixed volume. Now we discuss the different properties of solid, liquid and gas, and we understand by using this table that is on your screen. The first property is of mass. Solid, they have a definite mass. Liquid, they have a definite mass, and gaseous, they have a definite mass. So all three states of matter, they have a definite mass. Now shape. So you can see solid, they have a definite shape. Liquids, they acquire the shape of the container. Gaseous, they acquire the shape of a container. Now volume. So solids and liquids, they have a definite volume, but gaseous, they have a indefinite volume. Compressibility. Solid, they cannot be compressed. That is not possible. Liquids, almost negligible, and gases, they are highly compressible. Fluidity. Friends, what is the meaning of fluidity? When substance flow from one place to another place is known as fluidity. So here, solids, they are not possible because they are not fluid. Liquids, they can flow. Gaseous, they can flow. Rigidity. Solids, they are highly rigid. Why? Because they cannot be compressed. Liquids, they are less rigid, and gaseous, they are not rigid. Now diffusion. So solid and solid diffusion is slow. Liquids and liquid diffusion is fast, and gaseous is very fast. Now space between the particles. Solid, they are most closely packed. Liquid, they are less closely packed, and gaseous, they are least closely packed. Interparticle force. The solid, they have a strongest interparticular force. Liquid, they are slightly weaker than in solids, and gaseous, they are negligible. So friends, here we understood 3 states of matter and some part of this chapter. So now read the textbook, and whatever doubt, you can WhatsApp me on my number, that is 9016487991. Thank you.